Yeah. Now we are talking about average linkage. Now, previously, the lecture that was delivered was based on complete linkage after providing introduction to what hierarchical clustering is all about. But today we'll be looking at average linkage with an example. Now, just like we know that the average linkage is distance between clusters, which is the average distance between any pair of points from two clusters. So here we are looking at a correlation based distance between any of two observations. Now let's look at the example. Say suppose that we have 5 observations, observed points, each with 5 features. We represent the correlation based distance between any two observations with measurement on these 4 features in the following matrix. Okay, so let's look at this is 5 actually. So let's look at we have the table matrix table already provided here. So and so use the matrix with correlation based distance to perform hierarchical clustering using average linkage. Then draw the dendrogram. Now the first thing we need to do is to compute 1 minus r, where r is our correlation matrix. Now the first, having done that, we have this table. Now we can see that in the beginning all 5 points form their own cluster. These are 5 clusters, so that we need to separate in different clusters, at least a manageable cluster. Now the next is that we need to calculate the average distance between the pairs of each cluster. Okay, now then having observed from the table, the minimum distance is 0.04, which can be found between 2 and 5. Then, having known that, we now recompute the matrix. Therefore, 2 and 5 will form one cluster. So the new element as given, we have 1, 2, 5, 3, and 4, both across and down the table. Now, we now start 1, 1, obviously 0, 1, 2, and 5. So that can be separated as thus. That is average of distance between 2 and 1, then average of distance between 5 and 1. And from the table here, the distance between 2 and 1 or 1 and 2 is 0.9, as we can see. Then we have another 5 and 1 is 0.60 that we have in this table. So, and the average 0.9 plus 0.6 divided by 2 gives us 0.80. Then we go again from the table. We have 2, 5, then 3. Now, which equals to average of the distance between 2 and 3, distance between 5 and 3. Then, when we look at it, which gives us 0.55, 0.20. When you average it, we have 0.375. Then we have the next one is 2, 5, and 4. Then split it into 2 and 4. The distance between 5 and 4 again, we have 0.50, 0.30. When we average that, we have 0.40. Then when we look at these, all the distances, the remaining that 1 and 3 is already provided there, it's not a split. Then 1 and 4 is already given in the earlier table, we don't need to. So that's what we have there. Then the smallest distance is 0.36. So which means the next regrouping we are going to have is 1 and 3. So 1 and 3, 2, 5, and 4. Then we start again. We know that 1 and 3 is already known to be 0. Then 1, 3, 2, 5. We split that It give us 4 distances, 1 and 2, 1 and 5, 3 and 2, 3 and 5. Then we average. Now 0.90, 0.60, 0.55, 0.20. When we average that, we have 0.56. Then the next one is the distance, average distance, 1 and 3 and 4. Then we split it. We have average of distance between 1 and 4, then 3 and 4. That gives us 0.45 and 0.57. When we average that, we have 0.51. Then when we look at the smallest there, the smallest is what, when we look at this table, the smallest is what, 0.40. Now we now bring 2, 4 and 5 together. So, and that will now give us, at the end of the day, we are going to have 2 clusters. So, okay, there's the upper one, something is missing there, 4 is missing. Anyway, 1 and 3, 2, 4 and 5, and we can see that these are the clusters that we have, and 2 clusters. So those are the 2 clusters we have. So when we draw the dendrogram of average linkage, this is what we have, because we have 1 and 3, 2, 4 and 5 is a cluster, right? Then we merge them together as one, and that is it. And if we are to do single linkage, instead of average that we have here, we are going to be having the minimum distance, just like we did for complete linkage, that is a maximum distance. So if it was to be single linkage, in the case of these 0.90, 0.60, 0.55, 0.20, we look at the minimum, which is 0.2, and that is what we're going to write down. So yeah, good. I believe you have been able to get something from this, and if you find this anywhere, you'll be able to solve it manually with paper and pen, and the Python approach will be provided as follows. So it's a continuous lecture. Thank you. Here I'm back again. This time around is for the lab session relating to average clustering that was displayed above. Now the first thing we do is to bring in the packages required to execute this, and this includes numpy, scipy.cluster.hierarchy, matplotlib.pyplot. Then the next thing is to bring in the data array, the 5x5 matrix containing the correlation based distance. Then the next thing is to convert to condensed distance matrix using the function sch.distance.squareform. Then in bracket the matrix that is above. Now we move to the stage of performing the average linkage hierarchical clustering using the function sch.linkage into bracket condensed distance. Then we define the method to be average, because we are talking about average linkage here. Then the plot diagram, we have the procedure for the plot. The size is 8 and 8.5, that is xy 8 by 5 centimeter. Then we have the sh dot dendrogram talking about the labels 1 to 5. Then the plot title is defined, the x label, the y label defined. Then the grid, yes, is true. Then the plot. Then after the plotting, when we enter plt.show, then we have the dendrogram, and we can see that 2 linkages two clusters are defined here, 1 and 3. Another cluster is 2, 4, and 5, and you can see how they are in their separate state and in their combined state. So that is the approach, the lab session that's been provided using Python. Let's watch out for the next video, K-means clustering. Thank you for watching.